Welcome to notes on end behaviors of polynomials. Excuse me. Our essential question is, how do you determine and write the end behaviors of polynomials? First thing we need to know is, what is an end behavior? And an end behavior is what a polynomial does as x approaches infinity on the right side and as x approaches negative infinity on the left side. We're going to talk about it as a left end behavior and as a right end behavior. So now that we've gotten the introduction out of the way, a little bit more information about end behaviors is that they are determined by the degree of the polynomial and the sign of the lead coefficient. I want you to recall from Algebra 1 and Algebra 2 that the lead coefficient is the multiplier of the term with the biggest exponent. And usually our polynomials are in descending order, so it's usually the one at the front, which is why it's called the lead coefficient. An even degree polynomial with a positive lead coefficient will start up and end up. And so from the graph, here's an example. We've got y equals x to the fourth, take away 2x squared plus 1. You'll notice that the lead coefficient is the number in front of x to the fourth. It's my biggest exponent term, and so you'll notice that 4 is an even number. And the lead coefficient is the number in front of it. Well, it's a 1, so it's positive. And so we have an even degree polynomial with a positive lead coefficient. And so it makes this shape if you were to graph it. And so to describe our end behaviors, we write it in this particular notation over here. We say that as x approaches negative infinity, so as we look at the end of this side of the graph, where is it going? As x is approaching negative infinity, x is going to the left forever. What's y doing? Well, y is going up according to our statement above. So where is up going? Well, up is going to positive infinity. This is what we would call our left end behavior. Now we go do the same thing on the right side. Well, looking at the end of my graph, it's got a little arrow, so as x is going to positive infinity, as x goes to the right forever, what's y doing? Again, the y side is going up, which is positive infinity. So when you have an even degree polynomial with a positive lead coefficient, it's going to start up and it's going to stay up. And we write it as x is going to negative infinity, y approaches positive infinity. As x goes to positive infinity, y approaches positive infinity. So these are your end behaviors. Go ahead and pause, and we'll move on to the next example. Okay, second example. An odd degree polynomial with a positive lead coefficient will start down and end up. So in this particular example, y is equal to x to the fifth, take away 2x squared plus 1. You'll notice that my biggest degree exponent is a 5, which is an odd number. So this is an odd degree polynomial. And you'll notice that its coefficient is positive. And that's the lead coefficient again. It's a positive 1. And so this one, I would expect, even before graphing it, that the left side of it would be going down and the right side of it would be going up. And remember, we always read a graph from left to right. So it's starting down and ending up. So as I look at my algebraic way of writing it out, as x is approaching negative infinity, y is also approaching negative infinity. So on my left end, x is going forever to the left, y is going forever down. On the right side, as x is approaching positive infinity, y is going up, so y is approaching positive infinity as well. And this is my right behavior. Go ahead and pause, and then we'll move on with the next example. Now for the third example, an even degree polynomial with a negative lead coefficient will start down and end down. So in this particular example, I have y equals negative x squared minus 2x plus 3. My biggest exponent is a 2, which is an even number, so this is an even degree polynomial. And you'll notice that its lead coefficient is negative, and so my graph, even before I graph it, I would expect that it would start down and end down, so both sides would be going down. So as I look at the left side, as x is approaching negative infinity, y is also approaching negative infinity. Now it's my left end behavior. My right end behavior, as x is approaching positive infinity, as x goes to the right, the y value is still going down, so y is approaching negative infinity. Go ahead and pause and finish copying this down, and then we'll finish up with our last example. Okay, the final situation for polynomials is if you have an odd degree polynomial with a negative lead coefficient, it's going to start up on the left side and end down on the right side. So notice that our biggest exponent is a 7, which is odd, and its lead coefficient is negative, and so it's going to start up on the left and end down on the right. So as I look at my left end behavior, it's going forever to the left, and y is going forever up. So as x is approaching negative infinity, y is approaching positive infinity. And then as we move to the right end behavior, as x is approaching infinity, x is going to the right, y is going down, which is negative infinity. And so this is how you determine your end behaviors. Finish copying the notes, and we will see you tomorrow in class. Have a good day.